Hello, welcome back to For the Love of Math, friends. Remember, on this channel, I post content of a more advanced mathematical nature. All right, so take a look at this one here. Given f of x equals 2x plus 1, show that this quantity right here, so an absolute value x minus 1, given that it's less than delta, some number, this implies that an absolute value f of x minus f of 1 is less than 2 delta. This is the kind of question you might encounter when you're beginning to study limits at a slightly more advanced level. Okay, it's a kind of transition away from more routine math to perhaps a bit more rigorous form of math. So the question is, how do you connect what's given here with what's given here? We have to figure that out. Well, what can we compute? If you look carefully, we're given f of 1. We can compute that. It's really easy, right? You just evaluate the function. So let's do that here. So f of 1, we can find it's just 2 times 1 plus 1. That's going to give us 2 plus 1, which is 3. All right, so we know that this value here really is 3 in this position. That's good. This is f of x. We got to go from there to here somehow. Make a connection if you can. Notice that this is a single value. This is 2 of those, isn't it? We have to connect that. Well, how do you make a single into a double? You just multiply by 2. So take a look. I'm going to take x minus 1 less than this quantity, and I'm just going to multiply both sides by 2. We are allowed to do that. So I'm going to have 2 times x minus 1 is less than 2 delta. That's not bad because you see already like this piece here matches that piece. Okay, so now what we can do is by basic property, we can take that 2 and bring it inside this way. That's allowed. So we're going to have with an absolute value bars now 2x minus 2 is less than 2 delta this way. So the nice thing again, let me stress, right? This is already matching that. That's perfect. But then we have the following 2x. Now look at our functions. Got a 2x. So like this triple underlined piece matches, but this is a negative 2, whereas this is a positive 1. So something is not working quite right still. We got to keep going, okay? We're going to do a basic trick, which is add a really convenient form of zeros. So I'm going to have an absolute value bars 2x, and then I'm going to do plus 0 right here, minus the 2, still less than 2 delta. What is the convenient form of 0 here? Well, we got to keep in mind something. Like you see, the value of the function right here at 1, and when 1 went in, 3 came out, correct? So this has to ultimately, this is like minus 3, but this says minus 2. Okay, so that means, continuing, I'm going to proceed as follows. I'm going to write this as the absolute value of 2x, and then we write that 0 as plus 1 minus 1. Again, this is allowed because this is just 0, and then minus 2 is less than 2 delta this way. But look how beautifully this is working out now. Why? Because you see, this 2x plus 1, that's just f of x right there, isn't it? And then you can group this double underlined -1 and -2 into a 3 to get a -3. So continuing over here, I'm going to have an absolute value 2x plus 1, let's say within parentheses just to be very clear. Group these two together into a -3, and this is less than 2 delta. But of course, as we set out to prove, this f of x is 2x plus 1, so this is done, this part, right? And then f of 1 is just 3. In other words, to finally finish up, we can say that following is what we have found. In absolute value bars, f of x minus f of 1 is, as we said, less than 2 delta, right here, right? This is what we wanted to show, beginning from the fact that right here, right? This part, x minus 1 in absolute value, it was less than this delta right here. That allowed us to conclude that through the sequence of steps. Friends, if you enjoy mathematical content of this nature, please be sure to subscribe and like, and I will see you in another video.